We made a simple metal fence blueprint at the end of the previous video. Here is a short recap of how to do it. First, create a child blueprint from the mesh on Spline Parent. Then add an auto placement node, the total spline length node and the mesh on spline node and connect them. Compile and save and it should look like that. Let's duplicate this blueprint and change it to a blueprint for one of the wooden fences. Rename it to my wooden fence and place it in the level. A double click will open the blueprint. Replace the static mesh and the mesh on spline node to the wooden mesh module C180 by 120 from the fences folder named C. Compile and save. The fence modules fit perfectly, but the fence has no pole at the end. You could place a single pole at the end or a module that has poles at either end attached. In this example we use the second method. Move the nodes in the blueprint a bit further to the right. Then move the total spline length node to the left to create a gap. We'll need the segment dividing node A end between the total spline length and the placement node. The spline segment AN node can place a single mesh at the end of the spline and leave the rest to be filled by the auto placement node. I'll duplicate the existing mesh on spline node, connect it to the AN node and replace the mesh with the end variation of the C-type wooden fence. Compiling and saving will update the blueprint in the scene. It also reset the spline points in this case. But now the fence has a pole at the end of it. There aren't many options in the details panel yet. We'll need to promote some of the node variables to parameters. You can do that by dragging off the pin and then choose Promote to Parameter on top of the list. The new parameter will get the name of the pin. In this case, static mesh. The other static mesh will be named static mesh 0. Let's rename that to static mesh end. I'll resize my blueprint window and move the details panel to the right. I think that is the layout by default. One additional step is required to make the new parameters visible in the Details panel. Search for them in the My Blueprint tab and click on the little eye icons next to them. Now the meshes will show up as settings in the Details panel of the blueprint. We'll need some additional nodes to be able to change the material of the blueprint. There are modification nodes that go between the mesh on spline node and the placement node. Add the single material node and place it between the two existing nodes. It has to be done for both the standard and the end mesh on spline. I'll promote the materials to parameters and make them visible. Now you can add materials from the Mat folder to change the fence modules of the blueprint. We actually only need one material for both nodes. The module and the end mesh use the same material. I'll plug the material variable into both material nodes. Hiding the material end parameter will remove it from the Details panel. Let's change the mesh variables to the wider version of the fence. Replace the static mesh to the 240 version and the static mesh end to the single pole. The pole at the end doesn't align proper. We can change this with the overlap. Let's add overlap parameters for both of our static meshes. Call them overlap and overlap end. The overlap between the fence modules can stay at 0. The overlap end needs to be set to 18 to make the pole align. The pole is 12 cm wide, but it also has its pivot at the center. This means the offset or overlap will be 12 plus 6 equals 18 cm or unreal units. Let's create a separate 240 fence blueprint. Duplicate the original My Wooden Fence blueprint and rename it to My Wooden Fence 240. Now change the default values of the meshes, material, and overlap end to the values we figured out previously. Compile and save the blueprint. Place it in the level and the 240 meshes and the pine material will be already applied. I'll use the little reset icons to set the other blueprint back to its defaults. Now both fence blueprints are readily available from the content browser. Meshes that are actually bending along the spline are commonly called spline mesh. There are a few railing meshes that have spline in their name and can be used for that purpose. I'll add a filter for static meshes that allows to make them visible across subfolders and hide every other asset type. In the Railing Wood folder is one mesh we could use to follow the edge of this path. The wireframe mode shows us that it has extra vertexes where Unreal can bend it to follow the spline curve. Create a new child blueprint and name it My Spline Fence. Then place it into the level and add spline points to make it roughly follow the edge of the path. Open the blueprint and add a Spline Placement S node. This node will place spline meshes that can bend along the spline. It will fill the spline with the mesh. You can see that it does look a bit odd in some places. Spline meshes need a lot more spline points and they need to be more evenly spread out. Some additional points will fix the uneven stretching of the meshes. In other spots you may have to delete and reposition spline points until the placement along the spline looks good. Spline meshes are placed differently to standard meshes. The overlap does not work with spline meshes. You can't create gaps to add the fence poles. You will need to place the poles on top of the spline mesh. This can be done with the pole placement node. Add one after the spline placement node. Use the W1 pole mesh as the mesh on spline. The spline mesh placement has an output pin that contains all the points where the individual spline meshes connect. Connect this green array pin to the green input pin of the pole placement node. The poles cut halfway into the vertical railing bars, which doesn't look very good. It would be better if the poles were placed directly on top of one of the balusters. Replace the simple mesh on spline node with the one that has an offset. Promote the offset to a parameter. Then adjust that parameter until the pole sits exactly between two balusters. The first and last pole are not positioned correctly. We can use the start and end pole tick boxes in the pole placement node to hide them. We'll need to place them separately. Make some space at the start of the blueprint nodes, move the total length node to the left, add a segment FAF node between the total length and the spline placement node. The FAF adds fixed length segments at the start and end of the spline. Add a sequence node between the parent construction script and the spline placement. Then add a placement N amount node. This node allows you to place a single mesh. Connect the placement node to the start segment. Duplicate the pole mesh nodes. Rename the offset parameter variable. Do the same for the end segment. It's easier to make changes in the details panel of the placed blueprint. I don't spend too much time making the blueprint layout look pretty at this point. We need to adjust the gaps between the poles and the rest of the railing. Add parameters for the fixed length segments. It looks like 5 cm is a good size for the gaps on both ends. I'll clean up the blueprint layout quickly. The start and end pole are the same as the regular pole. Only the regular pole needs to have the offset feature. I replaced the mesh on spline node with a simple one for the start and end poles. I add an additional pin to the sequence to arrange the pole placements vertically instead of chaining them up. The static meshes used should show up as parameters in the details panel. The pole mesh for all 3 placements can be the same. I'll set the default parameters so the blueprint is ready to be placed. I forgot to connect the end pole mesh on spline pins. Now the blueprint is completed.